right, welcome geometry. Let's get going and give this a shot. So we're gonna do day 2, so it's either Monday or Tuesday for you right now. And we're gonna get started finishing up the notes from last Thursday or Friday. This is finishing up that section, all right? So you can continue on, and at the end, when we go to the Google Meet, you can just show me your notes continued from last Thursday or Friday. Today we're continuing to talk about line segments, and specifically we're going to talk about what it means to have congruent segments, and we're going to encounter our first formula for finding the midpoint. So first defining what congruent means, and we're going to use the word congruent in several different aspects. Congruent angles. Here we're talking about congruent line segments, congruent polygons. We'll get to that later, but just what does it mean to have congruent, in this case, line segments? So again, anything in blue, highly recommend you write that down. You may even want to pause this video right now to get a sketch of this and copy that down. Two segments that have the same length are going to be congruent, all right? So here I've got a segment AB. I also have another segment CD. And it also says that they are a length of 10, maybe 10 centimeters, maybe 10 feet, all right? We know that these things have a measure of 10, therefore we can call them congruent. They're the same size, they're the same length, they're congruent, all right? So, not equal, but think about it as they're equal lengths. And the way we can write congruent, specific notation, is we can write it like this. So, I have named this first line segment. I have it line segment AB, again with that line on the top. AB is congruent to line segment CD. So our congruent sign is just an equal sign with a little squiggly on top. All right? Again, numbers are equal to each other. 2 is equal to 2, 4 is equal to 4. But if we're talking about something with a geometric, I mean, it's actually a figure, right? The figures can't be equal to each other, but they can be congruent. So this right here, it literally reads, and I have it down here, segment AD is congruent to segment CD. All right, so that was congruent. We're going to use the word congruent in our next definition, which is defining midpoint. So when we're doing the midpoint is to bisect or divide into two congruent parts. Right now we're talking about the midpoint of a segment. Later we'll talk about the midpoint or something that is going to bisect an angle. So when we're looking at the midpoint of a line segment, it is the point that bisects the segment into two congruent segments. Again, I'm seeing those keywords of congruent segments, right? So if two segments are congruent, then they have to be equal in length. Let's say that you have this entire thing has a length of 10. I mean, this is kind of common and obvious, common knowledge, right? But I just want to go over it. So if this entire thing is a length of 10, then the midpoint has to be somewhere exactly in the middle so that it splits this thing in half, right? When I think of bisect, I like to think of dividing something in half. So the midpoint should probably be about right around here. And that would make this part right here would have a length of 5. And this part right here would have a length of 5. In my next slide, I actually put the midpoint on there. So let's just say that that is about the midpoint. And we have two congruent segments. And if you're marking something congruent in a figure, in a drawing, you can use these little slashes. And that says that segment AM, so this part right here, see how I have this other slash on the other side? That means that the other side has to be also congruent. So I could write segment AM is congruent to segment MB. And if the entire length was 10, then this part over here would be 5, this part over here would be 5. And hey, that kind of goes back to the segment addition postulate. if you add up this part, which is 5, you add up this part, which is 5, you should get the whole length of AB, which 5 plus 5 would give you that 10. Whoa, math. All right, you don't have to write this down, I just want to talk about it. So there's a couple different types of geometry. We're going to mostly work with Euclidean geometry, which we've had a line segment. It was floating in space. We can say some things about that segment, like it has a midpoint, we can bisect it, it's just floating in space, right? It's kind of what we call Euclidean geometry. We could put something on a coordinate grid where we have points, we have axes, the x and the y axis. So as soon as we put something on a grid and we start talking about the actual points, now we're talking about analytical geometry. And that's where we're going to jump in the next slide. So we just talked about the midpoint. How might we find the midpoint when we have a line segment that is on the coordinate plane? So here, trying to find the midpoint of a point at -1, 6. So I hope you can see this okay. I've got point A up here is at -1, 6. I've got a second point, which is, we need 2 points to make a line segment. So I have a second point at 4, 2. That's my point B down there. And if I'm trying to figure out what is the actual coordinate, the x and y coordinate for our midpoint here, I mean, we could kind of guess. I'm going to say that it's going to be somewhere around here, right? But I want the actual number. I want the actual coordinate for that midpoint. So if you think about it, think about like this. Hang on, let me get a different color. Think about the horizontal and the vertical distance between these 2 points. So the vertical distance between these 2 points, let's just think about it like this. Right here is I'll finish up that line there, right? Looking between these 2 points, this is a vertical distance, okay? So we've got 1, 2, 3, 4 units, right? And there is a horizontal distance as well. We'll get another color. I think that'll be okay. There's this horizontal distance between our 2 points as well, right? Just right here. So if you think about it, if I could find the average distance, the average horizontal distance, and the average vertical distance, then I would find something pretty close to right in here, right? I'd find some sort of coordinate point. If that doesn't make any sense, that's okay. I'm going to give you a formula here and we'll talk through it. So when I said find the average between my horizontal distance here and my vertical distance, could I just average the actual coordinates? Here's my x coordinate, -1. Here's my x coordinate of 4. Could I just average those numbers? Oops. All right. So this is your formula. You may want to pause and get this down as the midpoint formula. Right here. So essentially what it is doing, let me get the right color. Essentially what we're doing is we are averaging out both of our coordinates. So notice how I have x1 plus x2. That is referencing my x coordinate from my first point and my x coordinate from my second point. And then I'm dividing by 2, right? Averages, you add up the numbers and then divide by how many numbers you are adding. Since I'm adding 2 coordinates, I'm dividing by 2. Same thing over here. If I have the y coordinate from my first point and the y coordinate from my second point, I can add those together, divide by 2, and find the average. So, if you are given two random points, let's just say x1 and x2, I'm getting it mixed up here. Welcome back from summer. If you were given two random points, one of them was x1 and y1, and the other one was x2 and y2, you would be able to use this formula to find the exact midpoint between these 2 points. So let's use this information on our 2 points over here. And I think, yep, I got enough room. I'm going to go right up here. So here's my example. So I'm just going to use that formula. I'm literally just going to kind of write this out with empty spots. So here is the midpoint of these 2 points. What do I have to do to find the x-coordinate of the midpoint? Well, I need to add my 2 x-coordinates. My 2 x-coordinates in my original points are, we've got that -1 and we have the 4. So add them together and divide by 2. So -1 plus 4 divided by 2. Again, I'm getting this information from the original x-coordinates that I was given in the problem. All right, and we'll do some math with that to work that out. My y-coordinate, the y-coordinate for my midpoint should be, well, here again, I just took my y-coordinates from my original points, added them together, and divided by 2. So my y-coordinates from my original points here were the 6 and 2. I got that 6 and the 2 were in my y-coordinates over here. So I'm going to add them together and divide by 2. Okay, and this is just a little math we can work out, right? So up top here, I'm going to add these together first and then divide by 2, so step by step. -1 plus 4, all right, that's going to be 3 divided by 2. And then in my y-coordinate here, I have 6 plus 2. That is 8. Still being divided by 2. And then we can simplify this down, right? 3 halves, 3 divided by 2, just 1.5 we could say. So I'm going to put it in red. Here's the answer to my midpoint. So 3 divided by 2 is 1.5. If you want to just leave it as 3 over 2, that's fine as well. But we can simplify our y-coordinate over here even more. What's 8 divided by 2? That is going to give you a y-coordinate of 4. Okay? So I'm going to kind of erase this and clean this up real quick. Oops, I lost the 6. I'm going to get rid of this formula, all right? So those were our original points. Again, all we did is we took our original x-coordinates of -1 and 4. We added them together according to this formula and then divided by 2. To find our y-coordinate of 4, we took our original y-coordinates of 6 and 2. We added them together, we divided by 2, we got 4 there, all right? So that tells us that our midpoint should be at 1.54. And if we look, I do have that midpoint. I added it earlier with my slide. Ignore that. My midpoint is right there at about 1.5 up to 4. So 1.5, comma 4. There's our midpoint. All right, pause if you need to. I'm going to go to the next slide and erase this. Okay, if you want to pause and try it yourself, there is an example. Otherwise, I'm going to go through it together. So I'm going to rewrite the formula down here. If you were given 2 random points, let's just say we had x1 and y1. That was our first point, right? Our first x-coordinate and our first y-coordinate. And we also had x2, y2, a second random point, all right? Then the midpoint formula to find the midpoint, the exact middle between these 2 points in a coordinate grid, we had that formula of add the x's together and divide by 2, and also add the y's together and divide by 2. So if these were our completely random points, let's do just that. I'm going to add the x's together. I'm going to use that red for my example. So I see I have x coordinates of 8 and -2. So I'm going to put this in a point form. 8 plus -2 divided by 2. Again, we're taking that average. And I have a y coordinate. Again, add your y's, divide by 2. So I've got 3 and 15. And divide by 2. And now simplify this, all right? Again, we have to add the top before we divide by 2. So I'm going to do 8 plus -2. That gives me 6, still being divided by 2. Comma, what's my y? I've got 3 plus 15 and then divide by 2. So 3 plus 15 is 18. And then divide by 2, all right? And then we can simplify that. We've got 6 over 2, that is just 3. And then 18 divided by 2 is 9. So you should have gotten a midpoint of 3,9. All right, the point 3,9 is exactly between the 2 points here. All right, and again, if you think about it, here's one point, an endpoint to my line segment. Here's another endpoint to my line segment. They're somewhere on the graph. They would connect and make a line segment, and we were able to find our exact middle of the line segment, our midpoint. Okay, that was a lot, but you're doing good. Again, if you need to, just erase that, but go back a few seconds, pause and absorb, all right? All right, that was my answer. Okay, that was it for today. So I am clocking in at about 17 minutes. So let's do about 27 minutes. Yeah, that should be good. About 27 minutes into class. Come join me at this Google Meet with the nickname Blackman107 like you've been doing for a while. And I'll give you a couple minutes to get loaded in. If you're done early, come on and join us. I have a review problem for us. Make sure you're able to show me your notes somehow, and we'll go over some review problems. Then I will set you loose to work on the assignment. See you soon.